Thursday, February 5th, meeting of the Water Quality Management Committee will come to order. 3:30 in the afternoon, Selectmen's Meeting Room. First item on the agenda is a presentation by Jim Begley, MT Environmental Restoration, which is a draft Acapesco Peninsula Groundwater Investigation Report. Jim Begley.
Are we being televised? I think we are.
Yes.
Just one across.
Okay.
Let me give just a minute of background for our nationwide TV audience here. Okay. The town of Falmouth has 15 estuaries, of which 5 are on the south coast that are part of this planning process that we're going through. The first one, which the town has heard a lot about over the last couple of years, is the lower Little Pond, Falmouth Heights, Mara Vista area. But the other ponds are equally important, and one of the things that we've commissioned is this study you're going to hear about today, which looks at the next peninsula after the Mara Vista Peninsula, and looks at the groundwater in that area and to determine what might be the best course of action to deal with that water body. Great pond. So Jim.
Okay. Thank you very much. I really appreciate having the opportunity to be here, and I'd like to first of all acknowledge Nate Weeks, who I'm working with on this project. He's here. I don't know if you, anytime you have anything to add, please jump right in as I go through this. So we're going to talk today about the report that we've completed, at least in draft, which you all have a copy of. And there's lots of detailed information and tables and so forth in the report, so you can refer to that as we go through if there's something that...
I'm getting the word that you need to speak into the microphone.
Oh, okay.
You can hold it, take it out.
Take it out.
All right. I like to walk around a little bit. All right, so I'm going to talk about the Falmouth Acapesco Peninsula groundwater investigation work that was implemented to investigate that area to collect some initial data about the possibility of putting in a permeable reactive barrier. So this work was carried out through the fall. We put in monitoring wells out in the neighborhood, and I'm going to go into some details to talk about that. First of all, just to bring everybody back to ground here, the problem is nitrate getting into the coastal salt ponds, and this nitrate causes eutrophication, which is a over-fertilization. Too much algae tends to grow in the water, and that has a lot of effects, both aesthetic and affecting the life in those ponds. So that's the main issue that we're focused on here. The specific objectives of this work were to investigate a particular area on the Acapesco Peninsula, find out more about the hydrogeology of the groundwater system on the peninsula so we could have a better understanding of that, looking at the chemistry of the groundwater to see how that comes into play in considering a permeable reactive barrier, or PRB. And we also wanted to take a look at the possibility of finding the saltwater interface, so that we have a lens of fresh water that is likely sitting over salt water that is in the sand beneath the fresh water. And up to this point, we really didn't have any good information on where that might be. So we have some additional information on that now. And lastly, of course, we wanted to quantify the nitrate levels and other types of nitrogen if they're present, so that we can understand the concentration and how significant the nitrate might be in that area. And I want to stress that this is collecting some initial information. So we have limited data to start off. It's difficult to draw complete conclusions from limited data, but we have some information now to start with. So to show you where we're located, the black circle that you see there is what I'm calling the study area on the peninsula. It's about 3,500 feet out onto the peninsula south of East Falmouth Highway. Give you an idea of where it is. So it's not quite halfway, I think, down the peninsula, and it's adjacent to a section of Great Pond. We're working on the western side of the peninsula, so it's adjacent to Great Pond, and in particular the upper reach of Great Pond, which in the studies that have been done before and the estimates is a severely impacted part of the pond because of high nitrogen loading. So all measures show that that part of the pond is being adversely affected by nitrate. The main source of nitrate out in this area is leakage from septic systems. So the septic systems are sources of nitrate. As water leaches down from the leach field, whatever other forms of nitrogen might be there, like ammonia, are generally converted to nitrate. And then once they get into the groundwater system, it's fairly stable and it starts to migrate with the groundwater towards the salt pond. So the way we investigated this is we went out to the neighborhood and we put in soil borings and monitoring wells to collect information. And this is an actual picture from the work being done. Nice to see there was no snow on the ground at that time, and eventually we'll get back there. This was back in November, and this is a geoprobe rig, which is a direct push soil boring rig that's used to put in the monitoring wells. So it's working to hydraulically push a coring device down. We were able to collect soil samples, and then we're able to install PVC monitoring wells in the holes. And this is one of the first things that we found. The aquifer material is a sandy material, as you might expect here on Cape Cod, but we found that to the full extent of our investigation, to about 87 feet below land surface, we were encountering sand, mainly a medium sand, some fine sand in places, some coarser sand or fine gravel, but generally pretty uniform sand. And this permeable material is the P in PRB. When you think back of what we're looking at here, a permeable reactive barrier, water has to flow through it and the material has to be permeable. So we found quite permeable material. And this is a core sample of actual sand that we pulled up. And interestingly, you can take a look here. In this area, you can actually see it looks a little darker. That's the water table elevation. So the sand above that line is unsaturated, and the sand below that line, roughly, is saturated with water, and that's what we call the water table. And I'll refer to water table wells, and those are wells that have screens that kind of straddle this elevation where the sand becomes saturated. Kind of honing in a little bit on where we did the work, you can see 3 locations there, MTER 1, 2, and 3. Those are the monitoring well locations. At the MTER 1 location, we put in 4 screens, and that's the location where we went deep into the aquifer to see if we could find the salt water and to see what the stratigraphy or layering of the soil was all the way down to that depth. One of the things that we can do here is we can put in these monitoring wells and we can survey the elevations in so we know exactly where the top of that well is, and then we can measure down precisely and try to get the elevation of the water table itself. So the water sitting in that well will be at a certain level, and when we measure those 3 levels, we can find a slope within that area. So if you take a look here, MTER 1, 1.66 feet, that's the elevation of the water in the well. The well that's downslope from there, 1.58 feet, that's the elevation. So you can see from that that there's very little difference actually in the elevation. It's a pretty fine difference. So that very fine difference helps us with 3 points to find the slope of that water table and figure out which way it's going. What we found is the water is going to the northwest in this area. And we measured it a couple of times, got the same results. So the flow's to the northwest, the gradient is very slight, and we can use that gradient in a formula to calculate the velocity of groundwater flow. And the velocity that we found based on this slope and some information about the material, the permeability of that sand, for instance, and the porosity of that sand, we can determine that water flows here about 0.14 feet per day, or 51 feet per year. That's a relatively slow groundwater flow on Cape Cod. Other locations you might have 1 or 2 feet per day. That's considered fast. Then we looked at the groundwater chemistry. And groundwater chemistry is the R in PRB. It's the reactions that are going to take place in a permeable reactive barrier. So we considered a number of things when we looked at the groundwater chemistry. There are certain compounds that might be good for a PRB of a certain type. There are other compounds that may interfere with it. Sulfate is one that is kind of a competing compound for degradation with the nitrate. And we found that the concentration there was relatively low and not going to be a problem for a PRB. So we looked at a number of things like that. We found pretty high dissolved oxygen levels, which we would expect in this aquifer. That's not a great thing for PRB because oxygen is, again, a competing compound in the breakdown of nitrate, and I'll talk about that a little bit more. But it's always going to be an issue here on the Cape. We found in some of the wells in particular a lower oxidation reduction potential, and I'll talk about that a little bit more as well. But the fact that we found a lower number on this parameter is also a good thing to a certain extent. And we found pretty low organic carbon levels. That was, again, expected. Organic carbon is one of the things that you could add to an aquifer to create a permeable reactive barrier. It's the thing that would be used by the bacteria as food, and they would then work with that and break down the nitrate. Now, we're not going to go through a whole lesson on oxidation reduction potential and what all this means, but just a couple of things I wanted to point out here. The oxidation reduction potential is a measure that we use to see what kind of biological activity is occurring in the subsurface, in the groundwater system. And if you look over on the right-hand side, you can see some numbers there, starting up at the top with a plus 334 and a minus 699 down the bottom. These are very relative numbers. They're not specific. But at very high oxidation reduction potential, that's when you generally have lots of oxygen around, and there are bacteria that are breaking down organic carbon, and they're using oxygen for respiration. And that's the easiest way to make a living for this bacteria. They're getting lots of energy because it's high on that ORP scale. The next compound down is nitrate. So the next thing that they can use to respire in their metabolism is nitrate. So it's not too far below oxygen. And you can see as it goes down the scale, those numbers get much more negative. And it's less energy available for bacteria. So they'd always prefer to use higher on the scale if they can. Here's where we have our numbers. We saw in the salt water, which I'll talk about in a minute, very deep down, we had a very low ORP, and we, not surprisingly, didn't find any nitrate there at all. In the fresh water, we had a range of nitrate of ORP levels, but the highest one was plus 158. So if you take a look at the place where denitrification can start to occur, about plus 231, you can see we're actually in a range where there might be some denitrification taking place. Not necessarily, but it's possible. And one of the things that inhibits that is oxygen, and we did see lots of oxygen in the water. So there's a lot of interesting chemistry going on in the groundwater system. And again, this is the R in PRB, the reaction part. Now it gets interesting. We can take a look at some of the information that we found in kind of a conceptual view here. And this is a figure that I borrowed from CDM Smith. They had done this work for Falmouth earlier as a conceptual picture of what's going on in the groundwater system. And what we've done here is add some information so we can build on that conceptual model and understand a little bit more of what's going on. You can see the black columns there are the 3 monitoring points that we put in. And the MTER1 location is towards the center of the peninsula, not quite the middle, but still on that western side. But you can see that that's the location where we went very deep. And we ended up putting 4 different screened wells in at that location so that we have multiple levels to sample for the water. And we looked at the soil on the full depth there. One of the key things that we found was that about 75 feet down below land surface, we encountered the salt water. So it looks like it's actually true that the salt water completely goes under the peninsula, connecting from one side to the other with a freshwater lens above. It's not unusual if you look at the outer cape, the entire arm of the outer cape looks very much like this. The depths vary, but it's very much like this with salt water going under. You can see that the other 2 wells that we put in are just water table wells, so we don't have deep information there. We don't know how far it is to the saltwater interface out towards the edge of the peninsula, towards the pond. That's a gap in the information. We don't know, for instance, either whether the fresh water extends out under the pond. So you can see I've included a question mark there on the chart. So we have about a 50-foot thick lens of fresh water in that middle part of the peninsula. Again, we don't know how thick it might be on the outside. And the reason this saltwater interface is important is we need to consider how deep would a PRB have to go. So that's why this saltwater interface is important in the B, or barrier, of the PRB. How big does the barrier have to be? And that affects the cost of the barrier, the substrates that you have to add. The deeper you go, the more it takes. So it's an important factor.
And I think you need to indicate where potentially the barrier might be, because we don't want to mislead anybody. It's not going to be at the center.
That's right. And actually, losing control here. There we go.
There's a purple arrow there.
There's a purple arrow pointing to a line that was already on the figure from the work before. That is a potential PRB location. So a PRB would be out towards the edge of the aquifer, and it would not be in the middle where you'd have to go the full 75 feet. It's likely to be a shorter distance down.
Got a quick question.
Sure.
How difficult would it be to characterize, if you didn't want to go that deep and go half that deep depth, to try to characterize the flux that might be coming from just the top half to avoid having to go real low?
Yeah, it would not be difficult. I mean, it's just a matter of using the same type of multi-level well system that we've used, and you could find out what is the concentration of nitrate going down to see where the most significant mass is being transported out towards the salt pond. Definitely could do that. And I think operating a PRB, as long as it's designed to be truly permeable, you wouldn't have a problem not extending all the way down to the bottom of the aquifer either. You know, water's not going to flow around it in that case. Underneath it, it's going to still flow through it. So considering nitrate, nitrogen assessment, we looked for ammonia, for instance, and we didn't find any ammonia. And chemically, you would expect most of the nitrogen compounds to have been converted to nitrate as they reach the groundwater. We found the nitrate concentrations were relatively low here compared to some other areas that it's been investigated, even other areas on the Acapesca Peninsula. So these concentrations that we found in this study area, in this one round of testing that we did, were fairly low. And here are the concentrations on the plan view map. So at MTER1, I posted the concentration of the B screen, which is the second from the bottom. That's where we had the highest concentration at that location. 0.15 milligrams per liter. It's not all that far really from a background concentration of nitrate. We had a little bit lower concentration above at 0.13. It's not very different though, about the same. And again, at that location, all the way down in the salt water, we have a screen, and there was no nitrate detected at that location.
Steve?
Is the nitrate flux consistent with the MEP model?
I don't know at this point. I think that the concentration information we have is limited, so I would want to see a little bit more information before I could say one way or the other.
Sure, ideally you measured all over the place, but I mean, is it in the ballpark?
It seems to be on the lower side, I would say. It's not necessarily in the same ballpark as what they might have predicted. It seems to be a bit lower.
Another follow-up, would you say that we don't seem to be intercepting a significant amount of septic tank plumes?
It's certainly a
I
possibility.
mean, you would think that maybe
Yeah.
they don't go that deep or they go shallower, that
Well, one of the things that I think we need to consider is sort of the septic tank plume is going to
Plumette.
be a very thin, narrow line, if you will, in the groundwater system. And when you put all those narrow, small plumes together, they become a significant amount of nitrate. But any individual plume, it's kind of hit or miss when you're looking like this to see if you can catch one of those.
but for a neighborhood or like,
I think...
I know you weren't hired to study that and just
Right.
picking your brain.
No, go ahead.
No,
What's the question again?
well, any individual plume, but we have, I don't know, would you say 20 houses upstream?
Oh, easily.
In the capture area?
Easily, yeah. We don't know, it's a three-dimensional problem.
Okay.
And so some of the plumes may be going under the screens that we have,
Okay, thank you.
and some of them may be to the side.
Yeah.
What would the background number be if there were no septic plumes at all in what you were looking at?
Based on the research I did, it would be about 0.05 milligrams per liter.
And I think we need to point out that the lowest values were at the first site, which was the very deep well. And it actually is next to a wooded area where there are no houses.
Right.
So
Okay.
it's almost as if there are, quote, no houses upstream of
Right.
that. So you would tend.
So there's a wooded strip down the middle of that part of the peninsula.
Right, you can see a bit of
Fairly
it.
natural.
So when you actually were out on the site, it's not surprising that we found low levels. What's sort of more curious is the low but still elevated levels that are down on Shorewood Drive, which is the second and third monitoring wells.
Right.
But even those are not as high as in other places on the peninsula.
Right.
So there's either a great deal of variability in the measurements, or we didn't hit, quote, a plumelet from a septic system.
Right, so there's possible variation from time to time, and if we go back and sample these wells again, we might find something quite different. And there's also that variation from point to point.
How coherent are the plumes? I mean, if a plume starts out the width of a leaching field,
Mhm.
it doesn't start out at 0, it starts out 50 feet wide or something.
Oh,
Or
no
25
problem.
feet.
20,
No.
25 feet,
Yeah,
something like that.
then,
At most.
I mean, if it's a Title 5
Mhm.
thing. And then, let's say, the distance from monitoring station 1 to 2, how much does a single one of those spread out?
Not very much at all. That would be my expectation.
Does it double?
Likely not. Likely, it might, over half a mile, it might grow 25%, something in that order. But there's something that really affects that quite a bit, and that's when there's a contour in the groundwater. As if the water flowing down the slope is flowing on a slope that has a bit of a curve to it, if you will, then you can get some spreading just by flows going in a
Right.
diverging direction. But generally, plumes on Cape Cod tend to be long and narrow if they're in an area where there's no bend to the contour. They don't spread much at all because the technical term is the longitudinal dispersivity is quite low. We won't test you on that later, but
No, I hear you.
it's,
But there are hundreds of them.
there are hundreds of them, exactly.
Could they dive quickly? How fast do they go
Yeah,
down?
yeah.
And I
Well,
know
let me-
that's
let-
well
we can-
beyond my
We should
ability.
let him
We'll talk
finish
about
his
that
presentation. Here we
Let's
go.
talk about it here, because we have an image that gives us a conceptual idea of that. I've posted the concentrations at each of the multi-level wells there, the A, B, C, D levels, the A being the deepest, 0.05, less than that it was non-detect, 0.15 at the next one up, and so forth. You can see the conceptual flow lines in blue coming from the septic system leach field. So towards the center of the aquifer, the flow is probably quite steeply down as water moves away from those septic systems. And then it bends around, you can see the blue line coming back up towards the shoreline. Whereas the septic leach fields near the shoreline probably have a fairly straight shot for that plume to move out to the shoreline or discharge somewhere underneath the shoreline or beyond.
This may be out of your area too, but a seasonal house versus a year-round house. If a house, for instance, isn't used for 6 months, would you expect a pulse and then a non-pulse?
I would expect
So
some.
you may be hitting some non-pulses here, because there's a lot of seasonal houses in there.
There are. Now, we did this sampling in November, so it's sort of it's the tail end of the season, but I wouldn't expect it to have dropped off necessarily a great deal as far as being in the ground. Remember, the groundwater flow velocity here is very slow, so 50 feet per year. So things aren't changing too quickly because of that.
How many samples did you take? Was this one round?
Just one round of
This
samples.
is one
Yes.
round.
Yeah,
Yeah.
needle in a
Exactly.
haystack, yeah.
So,
So.
Preliminary.
It's preliminary, but you can get an idea of what's going on, and I have some other information about concentrations at other locations I want to bring up. And these are outside of the study that we did here, but they're locations nearby. And a little bit further south on the peninsula, the USGS put in a well last summer, and they've done some sampling. It's the yellow dot that you see over there near Green Pond, and I think that's the Great Harbors neighborhood. That's a little bit further south.
On the left.
On the left, yep.
Yeah, this is
And
not
this
in
is-
Green Harbor. Great Harbor.
It's not in Great Harbors, it's off Acapesket Road over towards
Green
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 Pond, yep. And they got up to 9.8 milligrams per liter, so a much more significant concentration. They have a multi-level sampling well that has very short distances between their sampling points that goes down to about 18 or 20 feet below the water table. And if you look at the profile, I don't have it here, but the information was sent to me, there's a profile of concentration, and they found very low concentrations right near the water table, up to maybe 3 or 4, a little bit deeper, and then a very sharp increase in concentration to this 9.8, which was at the deepest point that they tested. So vertically, there was a very significant variation in the concentration. So it's, you can have a lot going on at different levels. And that's likely to do with where the water's coming from. What the USGS saw at deeper levels was coming from someplace likely further inland because it went deeper and then out. And if we go up to the north, there's a study that's been done up by Acapesket and East Falmouth Highway, Route 28. And this was an investigation of a 21E site, a release of gasoline that occurred in the 1980s. And that investigation was pretty extensive. There was a lot of work done back then, both in putting in monitoring wells to assess what happened to the gasoline contamination, and also there was a lot of groundwater remediation work that went on to clean up that gasoline spill. But there are a couple of points of information that we got from that are useful here. One is the red arrow there represents the direction of the groundwater flow, starting up by Route 28 and heading south. And by the time that got about 1,500 feet south of Route 28, the water turned significantly towards Great Pond. And you can see that the water flowing from the mainland only goes a certain distance out and then is likely discharging to the ponds off to the side. If you look down to the south, you see we have our northwest flow direction here, and that likely indicates that there is a mound of groundwater out here that is kind of like an island mound of groundwater, and water is flowing radially off the peninsula.
Naturally,
Naturally
natural,
occur.
years ago,
It just, as the recharge occurs, that's what's going on. So that kind of accounts for what we're seeing with the relatively flat water table. It's not a steep slope because it's not something that's progressing all the way out from the mainland, pushing out onto the peninsula. It's isolated island type aquifer. It's its own aquifer, if you will. We know that down in the south in our study area, the groundwater flow is quite slow because the slope of that water table is pretty slight. Back up to the north, the water table has a pretty significant slope heading out onto the peninsula. And the velocity of groundwater flowing through that area is at about 2.5 feet per day, so much faster. We have some information because we did monitoring of natural attenuation of that hydrocarbon over time after the aggressive work done to clean it up. Then there was a period where residual was being monitored. And one of the things that was monitored was nitrate, because it's important in the breakdown of the hydrocarbon that was left in the ground.
could you
So-
explain,
Yes.
attenuation for the worldwide audience?
Certainly.
Would it-
So natural attenuation of the petroleum contamination is when there's a residual that is still above levels that you would want over the long term. There needs to be monitoring of changes to make sure it's protective of people in the area. And that monitoring is looking at the decay of the hydrocarbon, which is naturally occurring. There are bacteria that are using that hydrocarbon as food in the subsurface, just as they could use a source of carbon that we could add as a permeable reactive barrier substrate. And in doing that, they're using up the oxygen because they're using that in their respiration, and they'll actually use nitrate in their respiration as well while they break down that hydrocarbon. So in collecting the information, we looked at the concentration of nitrate in a well that was up gradient of where the release of gasoline occurred, and we looked at a well that was down gradient. And you can see in the up gradient well, we were seeing very significant changes in nitrate concentration over time. The lowest concentration observed was about 1.7 milligrams per liter, and we had as much as 12.5 milligrams per liter. So at one point, this was being monitored every 6 months, and I think it then went to a yearly monitoring. But you can see there was a very significant change in concentration from point to point when it was monitored. Down gradient of the petroleum that was there at the time, we saw very low levels compared to the upgradient part of nitrate because it was being consumed in the biological process that was occurring to break down the hydrocarbon. Towards the end, you can actually see the nitrate concentrations are coming up there. That's because that hydrocarbon is essentially gone at this point, and it's no longer being consumed by bacteria, and therefore the nitrate's not being used. Kind of a long story to tell you that there's much higher concentrations of nitrate up there to the north, and the groundwater flow is much faster. So the flux of nitrate, sort of across Route 28 in that area, is much more significant than the flux of nitrate that we might see out on the peninsula.
But that would be deeper.
We don't know how deep it would go at that point, yeah.
That could be a natural place for PRB if we could figure it out.
It could be, yes.
Did you say 2.5 feet a day?
2.5 feet per day groundwater velocity,
Right.
yes.
So that's like 1,000 feet a year.
Yes,
And down to the peninsula, it's doing 50 feet a year.
that's right.
That's an
It's a huge difference.
Yes.
That's all soil primarily.
Well, the soil is probably pretty much the same. It's sand,
Yeah.
but it's all slope of the water table.
Okay, what would influence the slope of the water table in such a short distance?
Well, the Sagamore lens is, at
It's
its height,
discharging.
is 60 feet above sea level.
That's right.
So
That's
that
right.
lens is
Oh, the
pushing.
hydraulic
Yes.
energy.
It's
going
it's
away.
all the way down to the
hydraulic
water.
energy that's
Yep.
driving it, right.
Okay.
So it looks like
Yeah.
it's pushing it down. When it gets to the peninsula, it's down. It's not, it didn't keep going.
Right, and that also tells you that most of the water that's coming down from the mainland is entering the Great Pond and the other salt ponds near the upper reach. It's discharging.
And that's a lesson we learned from the contamination from the base, that it upwelled in the bogs, not down at the water. So it's doing exactly the same thing here.
Right, where it's easy for it to exit.
Right.
If you could go back to the last slide, just for a minute. It's exiting where it's easy to exit. This data these data are useful in a number of ways, and so I just want to emphasize again, the upgradient well. Notice it's down at 3.4, 3.9, and yet it goes up to 12 and to 10. So there's a great deal of variability over the number of years that you've got plotted there, which is from 2005.
It's about 6 or 7 years, yeah.
To 2012. And so that has to be part of our thinking in terms of when we, quote, measure how much nitrate there is in a particular place.
The other interesting take-home lesson from this is, in the absence of a carbon source, the nitrate does not go away.
That's right.
And so for a PRB to be successful, there has to be a continuous supply of carbon. And the Nitrex systems, for instance, these alternative septic systems, use cellulose in wood chips as that carbon source. This is a carbon source that breaks down very, very slowly, so that it works over a number of years. And so one of the real challenges to figuring out how to make these PRBs work is how to supply that carbon in a continuous way that
Right.
is sufficient to be able to use up all of the nitrate that's present.
And also in a way that it can be applied in a way that you can get it deep enough. Even if you're not going all the way to the saltwater lens and you want to treat some portion of the aquifer, you need a material that you can inject in these kinds of situations.
For people that weren't in previous meetings, that translates into emulsified vegetable oil, which is not necessarily acceptable to a lot of folks, but it's a technique for injecting a liquid form
Right,
of carbon.
it's a long-lasting substrate that's been used for this kind of application for permeable reactive areas in a number of locations, yes. Yep. Okay. So to sum up our conclusions or our observations, we found the freshwater aquifer is about 50 feet thick out in the center of the peninsula where we did that boring all the way down to the deep levels. Groundwater chemistry in the area is generally conducive to designing and installing a PRB. There's nothing that we encountered that I would say would interfere with operation of a PRB or make it overly expensive compared to some other location. However, we did find that both the groundwater velocity is slow, and at least in one round of testing, which, as you see from that other graph, doesn't necessarily tell you the whole story, but with one round of testing and the slow flow, the mass flux of nitrate that might move across a line that you would put in for a PRB is not high. We know from some of these other locations, for instance, the information from up by Route 28, that there are possibilities in other places where you would have a high flux, mass flux of nitrate because the groundwater velocity is fast and because the concentrations of nitrate are higher. So bottom line is there might be a better location for a PRB based on this limited information.
Comments or questions?
And ready for questions.
Yes.
Did a great job.
Thank you.
Is it possible, looking at that peninsula, you're getting these tiny readings of nitrogen on the west side, and they're getting high readings on the east side. Is it possible that this presumption we all have that it splits down the middle and everything goes to its adjacent water body might not be true? That it might actually be heading over more to the eastern side and not to the west at all?
If there's some reason that there's more recharge on one side or the other, it could shift the high point of the aquifer.
Yeah.
But likely at some point there's a high point and it moves out one way or the other. It may not be in the middle. It might be off to one side, but it's likely flowing in both directions.
Could you flip to the picture that shows the geoprobe being installed?
Mm-hmm.
About midway through. There you go. That's just a van, like a van that delivers a rug or a piece
It's
of
like the
furniture.
milkman's truck. Basically.
And I just want to make that point, that we should be able to do quite a bit of investigation without being disruptive to the neighborhoods. Because we were able to get down to nearly 90 feet just with that equipment that you see in the back of the van, and it's really just pulling it into somebody's driveway. And so I think that as we move forward, we need a better picture of the hydrology and geology of these peninsulas if we're going to make a smart decision on PRBs. And that we basically have equipment that is so much simpler than what we originally thought we'd have to deal with.
It's a pretty quick operation too.
Yeah.
I mean, this device can push down through sandy soil quite easily. I think they could, if they just went without sampling from the top down to 80 feet, it could be done in about an hour.
Steve?
In a way, I'm supporting what Virginia just said. First, I really liked your presentation and your report.
Thank you.
It's one of the best ones I've seen in several years of being on this committee.
Thank you.
Especially compared to certain other ones that I won't name that have much
Thank you,
repetitive
Steve.
material. I won't name it. And but what it tells us, I mean, the honesty of it, is that we need a huge amount of additional data to know what we're doing on this. Because you have these narrow streams that are chopped into 2 or 3 month segments with blank 9 or 10 month segments in between for the seasonal properties. And they're narrow, and the number of samples that you have to take to get a picture of that is vast.
Well, it's significantly more than we've done so far, but I honestly think that we would be able, I'm just going to take Shorewood as an example, we would be able to put both multi-level and more and get a better characterization.
And record over time.
And record over time, that's correct. And we would be able to do all of those things with a reasonable expenditure of money.
Virginia, I would suggest, and I'm going to go way out on a limb, but my feeling about this and the preliminary data suggested very strongly to me that going after permeable reactive barriers around a peninsula is not the way to go. And what
Around-
you need,
around
you
the
need
peninsula.
to look for hotspots.
It's right.
And so
Yes.
PRB is going to be most successful if you can find a place, and we know from the geology of the Cape, as the outwash plains were formed, that you had creeks with gravel, and you can see on beaches where you get ulva in very hot spots, that's a place where the groundwater is upwelling very rapidly. And if you can find places like that and stick in a reactive barrier, that's where you're going to get a big benefit. But for us to be thinking about them as, enveloping a peninsula, I think is a non-starter. To me, it's like the little Dutch boy with the finger in the dike. Instead of going after the source, you're trying to stick your finger in it at the other end. And
The key thing that follows that is the thing you're looking for, those sweet spots where you should put these PRBs, is where you have the highest mass flux. So highest concentration, fastest flow. That gives you other challenges in maintaining enough substrate to keep it treated, but it's going to be the best location. And if you move up towards the
28.
upper reaches of these ponds,
28.
that's where you get to the point where the groundwater gradient gets much steeper, so the hydraulic push that's moving water through the sand is much greater. And at least from what little data that we've seen up that way, there's some significantly higher concentrations of nitrate. At least we found it in a small area.
I think there are technologies available now where you can go around the ponds and actually identify where those hot spots are. You can actually see by looking at the chemistry where
In the water.
in the water.
Yeah.
I think Dr. Kerfoot had something like that.
Right. I would agree with that to some degree. I think septic systems within 100 feet of the ponds would clearly show up as signatures going around the pond. But because you also have regional flow coming in, it's more likely to rise up farther into the pond. And so if you're doing a perimeter around the pond, you're not likely to pick those up. But I think as we assemble these pieces of information in terms of flux and groundwater contours and direction and so on, that eventually we'll be able to make a coherent picture out of this. And I just want to mention in that context, you see 3 peninsulas here, and if you move over 2 more, you get to seacoast shores. And the U.S. Geological Survey is still working on its information out there, but they also came across this rather low, slow groundwater contours. So ultimately, hopefully, we'll have a coherent picture.
And again, if you think about it, if you look at these peninsulas, you have recharge of about 25 inches of rainwater a year, which is performing that lens. But you're also importing 150 gallons of drinking water. We're pulling water out of our
Per day,
aquifer
to each
in
house.
Long Pond,
Yep.
and we're pumping it in. So
Yep.
that when the Indians were there was nothing but the 25 inches of recharge.
That's right.
There's now the 25 inches of recharge plus everything that we pump into each of those houses, and especially during summer.
Yep. Very good point.
I also want to just take a moment to thank the residents on Shorewood Drive and Seaview Drive and Harborview that put up with us while we were out there doing this work. So thank you.
Thank you. Any other comments or questions on the report? Thank you. Thank you very much.
Turn the lights back on.
Next item on the agenda is a discussion and vote on the Bourne's Pond Inlet Widening Flooding and Coastal Erosion Analysis Report, which we all heard a presentation on 1 week ago in this room. Comments or questions on that? I'll take a motion.
Well, in all honesty, I am aware that one member, who for some reason is not here, did have a number of questions on this report.
Could we know what those are? Can we go through those with our people here?
That's a good point.
And ask those questions as though Ron were here. And
All right, up to a point, yeah, I guess we could.
And if we're satisfied with,
Virginia, you want to be the interrogator?
No, no,
But who has a copy of Ron's observations? Okay.
Thea, do you want to start out? Consultant to consultant.
She'll need a microphone.
oh,
Share, I can share. Oh, thanks. Yeah, if Chairman, if you'd like me to walk through the points that were raised briefly, and Nate can respond.
Or whoever has a
an
response,
answer.
sure.
A good answer, okay. The first, Ron Zweig, who's not here, circulated at 7 PM yesterday, set of questions. It was 5 pages. There are tables from the MEP report that are cut and paste, and from the Bournes Pond Inlet widening reports as well. So the first question had to do with what the reconciling the present watershed load and the other contributions that are found in the MEP report, Executive Summary 2, and then the Bournes Pond Tech Memo. And that first set of questions, there are 3 different numbers, but if you add them up, they're the same. So if you look on page 2 of Ron's email, there's Bournes Pond, Israel Cove, and then a Bournes Pond system total.
Which is the page in the report?
It's not in the.
Don't look at the report, you have to look
No,
at
You have
Ron's.
to look at Ron's email. if you-
So,
right.
in his email, there's a table, just so you see. And it was basically a question of, why do the numbers look different? And the answer is because the way the MEP report wrote those numbers, it was following a TMDL protocol format. And when it was pulled by Applied Coastal, they were using numbers taken from a different table. But if you add the numbers up, they're the same total. So we've got Bournes Pond, Israel's Cove, and Bournes Brook in one, and just Bournes Pond and Israel. But the numbers are the same. It's 14.95 in both cases. So easy resolution to that one. The second question has to do with there being a number in the Bournes Pond Inlet Widening MEP report. There was an addendum where the Bournes Pond Inlet was modeled way back then. And it was modeled at 100 feet widening of the inlet, and some analysis was done. And Ron's question, he makes a statement that, based on his calculations, the increase in the water level is higher. Instead of being 0.12 inches, it's 2 inches. And the answer to that, I think, has to do with when the modeling was done for the MEP report, they were modeling a 100-foot inlet, not a 90-foot inlet. And John Ramsey went through very carefully last week exactly why the tidal prism calculation is what it is. And I would say that it's a more refined model than the historic MEP. The MEP report, when they did that modeling, it was a very 30,000-foot view. It was very quick, sort of, does this make sense in general terms? Well, when John did it through the subcontract for GHD, it was a very detailed analysis with site-specific, contours taken and the LiDAR and all of that. So I would say that what John Ramsey's published report is a more accurate, refined number.
Which one was Ramsey's, the higher number?
The lower
The
number.
lower number.
For the depth change?
Yes, for the increase in depth.
and if you remember looking at that graph, what basically the widening of the inlet was doing was reducing the offset. And so there was not an increase in elevation.
I thought it was of the order of an inch that he picked up by essentially doubling the width, which is what is proposed. He picked up an inch of elevation in the associated volume. An inch or two, didn't he? When he gave his, I mean, I agree, he seems to be a very careful, very sharp guy.
Like all our
But I do see the inconsistency in the numbers that Ron brought out.
Right, so
I
I
want to go back and paraphrase it again. The MEP report is from 2005, and it was based on some bathymetry information at that time, right, Nate?
Right.
Okay.
Right.
The Ramsey report that it was done in 2014 and 15, he specifically went out and redid all of the bathymetry, and he's dealing with a 90-foot width, not a 100-foot width, right?
Correct.
Okay, so you would expect the numbers to be somewhat different.
You wouldn't expect a 10% increase in width to make a tenfold increase in depth change.
That's correct, yeah, that's a pretty big difference that I can't reconcile, from looking at his comment. I just don't quite understand where he's coming from on it.
But why don't we kick it back to John Ramsey and ask him?
Well, I think the question isn't stated as clearly as it might need to be.
I'm sure.
Okay.
Try sending it to John and see what he says. Or do we want,
I'd like to, does anybody have a copy of the most recent Bournes Pond Inlet report
Yes.
with them?
Yeah.
On page 3 is where he's taking that .01 foot. So I'd like to make sure we got that right.
It's not.
Page 3?
Page 3?
Ron cites, page 3, thank you,
That's
as,
the preface.
as where the
Can't be page
the height difference is.
It's not page 3.
It can't be page 3,
And it
that's
can't
the
be
preface.
page 3.
No, that's
Right.
a wrong reference.
So I think there's some inconsistency there.
Inconsistency there.
Now, let me just look and see, I mean, maybe if you wanted to take a second and see if you
Yeah,
can
you know,
find where he talks about the height
Since
change.
Ron's not here,
Oh,
since we
it-
can't
it's
find
actually-
major
We're gonna
emphasis
move on.
Let's move along.
It's not the flooding and coastal erosion analysis, it's the earlier report,
Yes.
BP
Oh,
one?
BP1.
I got this.
which I also have.
Oh,
Okay,
I've got that.
thanks.
so what's page 3?
It wouldn't be page 3,
It's not page 3 of that either.
but that's the report it would be in.
All right. Well, there's a question that, and I think the finding from John Ramsey for the height increase is one that is based on a very rigorous analytical modeling that's ground truth. And I think that's the answer to whatever the question happens to be.
So what's the next
So I'm going to
question?
go on. There was again a question of where some figures were derived and how, the main question is how was the removal of 1,995 kilograms of nitrogen calculated? And the answer is John did a very thorough job at last week's meeting explaining what he did to calculate that number. And I could summarize what he said for the board, but it was based on the volume of water. And what they did is they ran the model, the hydrodynamic model, to a point where the nitrogen concentration at the Sentinel station met this increase increase in tidal volume. And when that model ran itself, they found that at that point where the Sentinel station number was what it was, it equaled an equivalent of 1,995 kilograms that would not be in the water because of the volume change.
Yeah, and that is clearly stated on page 39 of the technical memorandum BP1.
Which
So-
page?
Page
Page
39.
39.
Of BP1. Okay.
Yeah.
And then the last set of questions have to do with the incremental benefits. In other words, the question from Ron is the inlet widening and the cost of inlet widening and the kilograms of nitrogen that inlet widening removes is compared to sewering. And I think the first question is, why was the number $46,000 per home used instead of the 25,600, which is coming out of our Little Pond project? So,
And that's very well described in technical memorandum BP-1. It's based on the costs that were incurred for the new Silver Beach sewer project, because it's not just sewer extension, which is the main part of the Little Pond Sewer Service Area Extension. In New Silver Beach, it was sewer extension as well as pump stations, as well as treatment, a brand-new treatment facility, as well as new recharge facilities. And the costs that were used in that evaluation were based on the costs for New Silver Beach.
Total cost.
Yep, total costs, yep, in terms of the cost for all of the contracts that were let for the 3 different phases, as well as the engineering that went along with it as well. And they were information, it was very good information for what would be called a neighborhood type of system that would be handling the same sort of number of houses as was envisioned for the Bournes Pond area.
Now, in your presentation last week, you gave us a range of the number of houses that would be serviced, wouldn't be serviced because of the pond opening, and it ranged from 200 and some to 400 some. So which number did you, maybe that would have a huge difference in the per household cost of the back end report.
Yeah, it's in there.
Which number did you use in coming up with your number?
I used the number of homes that were serviced in New Silver Beach.
200 and some. 220.
And so, let's see.
210.
Number of assessed properties that were there was 231 properties
Okay.
for the New Silver Beach project.
But here we're comparing it to the number of houses that would not have to be sewered because of the pond opening, which was.
Right. My sense of this is that the $47,000 per house is a number that includes the collection system as well as the treatment. The number that Ron is citing for Little Pond is the cost of the collection system. So if you're going to, just to keep these two things separate, the first question is, what number is the appropriate number to use for a sewer cost per household?
Right.
And I think that Nate explained very well why he used the 47,000, and it's appropriate because sewering includes collection as well as treatment. So the 25,000 is not an appropriate number, that from Little Pond. Little Pond is a project on the margin of an existing project. The second question is, how many houses does this 1,995 kilograms equate to? And Nate gave us a range because you can think about how much kilogram comes out of a house in different ways. And legitimately, there are different ways of saying, is it 5 kilograms per year or is it 7 kilograms per year? And it really depends on some of the metrics you're using. And so Nate gave us a range of 2.1 to 3 point something times better pricing. I'm sorry, I'm not saying that well. But
Yeah.
he gave us a range, and that 2.1 to 3 point something is the 200 houses to 400 houses. So it's one or the other, depending on how much nitrogen comes out of a house.
And it also becomes even more complicated than that, because when you follow the rules of the Massachusetts Estuaries Project of how much removal actually occurs from the septic system down to the water table, and how they make the assumption of 26 point something that's actually hitting there. So one of those numbers of houses has to do assuming 35 milligrams per liter nitrogen going down, which is typically readily accepted in the engineering community, versus the 26, which has sometimes been called into question. So that's why using those two numbers generated the range in the number of houses that would have to be served to take out the equivalent.
So we've answered Ron's question.
Yes. And then the second part of that question is, we've compared it to sewers, why not all the other alternatives? And I think the answer to that is that when you are looking at non-traditional technologies, these alternative technologies, the fallback, the Plan B position, is a traditional technology, which is sewering. Or, as Ron points out, you could look at IA systems. And the answer, and what we found when we were looking at Oyster Pond, Wright Pierce did a very rigorous analysis of the cost of innovative alternative septic systems, enhanced, advanced, nitrogen reducing, and found that the costs were significantly higher than sewering. So that the sewering, if you were going to pick one traditional, sewering would be much less expensive than the IA systems. So
That one, yeah.
Mr. Chairman?
Yeah.
this is the one part where I most agree with Ron's objection, because if you do that, then you really should say that we've concluded globally that IA systems are not worth looking at, because they're always going to be more expensive than sewers. And I don't think you want to say that.
The two watersheds we looked at were saying.
I mean, it's not just a matter of picking a reference that we all agree on, it's comparing it to the next best thing, whatever that might be.
Say one thing? Sure. First of all, we don't have an IA system we're comfortable with. You can get to 3. The
Okay.
best is 5, and then we'd reintroduce it back into the system. So that would cause additional work. The other thing is Virginia always says, everything is site-specific. This was an approximation on a watershed that would be fairly expensive to sewer if you consider bringing it all to West Falmouth, which is almost impossible, or locating one on the peninsula, which probably is
Also impossible.
equally
Right.
possible. And then you get to the eco-toilets. Well, our experiment to date has said, we're not sure if the nitrogen removal is as effective as we thought beforehand, or if they're as socially acceptable. So
Right.
I think it's easy to conclude for this watershed, for this study, that inlet widening is the most cost-effective solution right now, not after we widen it and we see how it just gets dispersed or other things. But to me, it's fairly.
I agree, but I think we should say that, because this inlet widening is more than a demonstration project. It's part of the permanent solution for Bourne's Pond.
Yes.
We are making a final decision on part of the final system.
Yes.
So we should make a case that this is the best way to do it, that everything else is worse.
Well, we've made that
We
case to the
did.
committee and to the town meeting and to the voters twice in the last 3 years, so I think the case is pretty well
Okay.
made.
Yeah.
And if, other people may want to revisit the cost comparisons, but we're not.
Okay, and last but not least, there was the question about the sea level rise and why John Ramsey chose to use a more conservative estimate as opposed to the wider one. His answer to that question, having just done the minutes, I know exactly what his answer to that question was, is that you pick, because these sea level rise estimates are at best going out, 75 years, a guess, and the data is constantly being looked at from different perspectives. When you have life-threatening infrastructure like nuclear power plants, you pick the most conservative estimates. But when you're looking at things like bridges, you pick a less conservative, more middle-of-the-road estimate because there's no life-threatening mistake that you'd be making. And that's why he picked that number. And he does this up and down the eastern seaboard. And so those were his reasons for picking the numbers he picked.
It's fair to say if he took the most extreme possibility of 3.5 feet, the question of whether we put a bridge here or not would not be the question Falmouth would be asking. He would be asking, where did our waterfront go? Because we haven't got any anymore. It would be such a magnitude of an issue that this would be an asterisk in the conversation.
Yep, and John said that too, actually, that if we have this 2.8 feet, which is an extreme, we don't have Woods Hole anymore.
Right.
And he went into that.
I agree with that. And another way of
God.
looking, Mr. Chair, another way of saying what you said is that the investment in the bridge is small compared to the investment in the real estate on those peninsulas. So,
A robust discussion was had on Ron's plate.
Right. Any further discussion on the question of should we vote on the Bourne's Pond Inlet opening report?
No, I don't think anything has come up that would say this report was incomplete or that there's something else that was missed that wasn't evaluated. I think this is ready to forward to the selectmen and for us to take the next step, which is a very long regulatory path that we're going to have to go down, but that we recommend to the selectmen that they notify MEPA with a notice of project change.
Okay, well, that's the next item. This item is to vote to accept this report.
All right, I move we accept this report.
I'll second.
Further discussion? All in
Who
favor?
seconded? Did you, John?
All in favor, signify by saying aye.
Aye.
Opposed?
Aye.
Yeah, none opposed. Next item on the agenda, discuss and vote recommendation to the Board of Selectmen to proceed with filing of notice of project change with MEPA to widen Bourne's Pond Inlet. The motion on that one?
So moved.
Second?
I'll second.
Further discussion? All in favor, signify by saying aye.
Aye.
Opposed? None opposed? Great. Next item, discuss and vote recommendation of the Board of Selectmen to apply for $75,000 in funding from the Cape Cod Collaborative. You were sent, I believe, a copy of the proposed letter to the collaborative
I'm going to talk again, sorry.
from the town. It's a two-part request. Shellfish propagation, we wanted $50,000 for the monitoring of the third year of the Little Pond Shellfish Project. And we wanted $25,000 for more of the work that's been done in Acapesket regarding groundwater monitoring evaluation. So the selectmen have to okay the application before it goes to the collaborative, and that's why we're asking them to do it. Discussion? Motion?
Move to accept or approve.
Okay.
Submit the letter to the
Submit the letter.
to the
Okay.
selectmen.
Been moved and seconded.
I'll second.
Second to do that. Discussion? All in favor, signify by saying aye.
Aye.
Opposed? The ayes have it. Next one, the Woods Hole Sea Grant. Did something get sent around on that? I don't think so.
I only,
See it.
No.
well,
Why don't you, this is your baby, so let's talk about
I'll
this.
just describe. I didn't send it around because I didn't want to write the whole thing up without the board, without the committee saying it was a good idea, so it's sort of a little bit of chicken and egg. The Woods Hole Sea Grant provides funding for a number of research areas. Two of their main program themes are healthy coastal ecosystems and sustainable fisheries and aquaculture. And I've been working for the committee with the division of, with DMES, so Matt Weeks, Chuck Martinson, and that department, to look at oyster reef restoration and locating of reefs. And we have a viability study demonstration planned for next summer to do some reef development. And one of the themes that has come up consistently with shellfish aquaculture is the issue of genetic diversity and whether hatchery seed is good for long-term reef propagation. And so the idea came up to think about if we could take the wild stock of oysters. We've seen 4 or 5 inches in Wild Harbor, around Noshawn, in areas of West Falmouth. I mean, big old oysters, that are probably 10 years old. And the idea would be, instead of buying remote set, which is the shell that has the seed on it already, from a hatchery that comes from a very narrow gene pool, because it's their hatchery genetically modified seed, to try to create remote set using wild seed. So collect the seed, have it in tanks, get it to set, and then create remote set that's got a greater genetic diversity, and then watch and see if it makes a difference. And so this was the idea that I had. I've talked to Scott Lindell, who's the shellfish aquaculture. His specific title is the director of the scientific aquaculture program at MBL. He is very enthusiastic about this as an idea. Matt Weeks is also very enthusiastic. He thinks it's actually a terrific idea. And so the idea would be apply for a grant that would fund doing this project, creating the remote set, and then doing an experiment where we grow it for 2 years and watch growth rates. I would want to do a DNA analysis so we could count alleles and see if we're actually getting the kind of diversity we expect, and see if over even a longer period there's a hardiness in the natural, in the wild set versus the genetically modified hatchery set. So it's to do that analysis, and that's the grant idea.
Would we do a reef using this locally developed set?
Yes.
And one using the genetically modified out of the
Hatcheries.
hatcheries?
Precisely, and we'd compare them,
Just to compare them, okay.
control and variable, yep.
Okay, yeah,
And they'd be in the same estuary?
They would.
Yeah.
They'd be next to each other.
Yeah.
interesting. Sure.
One of the things of going to ACK, whatever they were, was the ability to make sure they were disease-free. That would be built into this, that if we have seed, natural diseases that the local seeds may have versus something in a controlled environment.
Right, we would have to do that testing that we do before we use it. So one of the things that's going to happen in this grant is regulatory. There's going to be sort of the finding, how do you work with regulators to do something like this? So that's absolutely right. They're going to require certain relay testing and this and that, absolutely.
Sure.
That's a really good point, Jerry.
Any other questions?
So the grant would pay for all the costs of this?
My understanding is that there is a match that you can use for in-kind. So we would count the hours that we would be spending in-kind, mats, and then the grant would pay for the seed, the labor, the
Testing.
research, the DNA analysis. I haven't worked out the budget because I wanted to find out if it was the committee's
Matt's
budget to do
time
this.
and your time.
Yeah, I would be, and Scott's time. We would figure out the
And
amount
our
of time.
committee is paying for your time, but not Matt or Scott.
Right.
And the in-kind would be, you guys are worth $25 an hour. when you
Well,
meet
Scott
your
would be
bank.
getting money from Sea Grant.
The Sea Grant gives an average of $50,000 in these grants, and they want 50% in local match by way of labor.
So if we ask for $20,000, we have to have 10
Okay,
in
right.
in-kind.
So if we ask for 50, we have to have 25 in kind. But it would not be extra, we wouldn't hire extra people, it's the people we have already
Right.
Correct. In this board,
in this board, right, and you and me.
$25 an hour.
For each one of you.
You're worth more than that.
Well, yeah, a little bit more.
It seems like a motherhood and apple pie, no-brainer, a good thing to do, but I just want to make sure it's not distracting from the core water quality studies, the statistics of it, or your focus on getting whatever data we need out of it. You know, just as, we're not going to research better tractors to put in PRBs. At some point, it goes beyond the scope of
We
what
have been talking
we're doing.
about oyster reefs for a while.
Yes.
So this kind of
Yes,
slides
yeah.
into that.
And this is a really important, even being able to create our own remote set will save us money. So one of the benefits is we are going to be buying remote set if we're doing a reef project. And so this would actually be money that would purchase the remote set to the tune of about $5,000. Because that's about how much 500, the bags are remote set. So the idea would be that the grant is actually covering an endeavor that the committee had been planning to do in terms of this reef development.
Right.
And then we use in kind to,
Last year, they were looking to buy this remote set, and we were finding it was very expensive. People had an outrageous.
Couldn't find it.
$100 a bag.
Right.
And if you need 500 bags,
So
it's
the ability to
crazy.
develop it ourselves is probably worthwhile. Virginia?
In terms of scheduling, my understanding is that the grant proposal is due the end of February. And are you saying that, two things, we need the selectmen's vote to submit before the end of February? And when would you actually have the draft that they would be approving ready? Okay.
Now I'm thinking
Close-
about it.
Close to being ready, okay. So the pre-proposal is fairly short, like.
It's 2 pages.
2 pages.
Working on the
Okay.
budget. The budget is the thing.
All right.
And in the past, the committee has not asked the Board of Selectmen to submit pre-proposals.
Oh.
They've asked them to submit the full proposal and accept the award if it's granted. So we could, in this case, because it's the beginning of February, if the committee votes to do it, try to get it early on the Board of Selectmen agenda and tell them it's a pre-proposal. And we would ask that if the pre-proposal were approved, that we would be able to submit the full proposal.
Okay.
And could I interject, when that goes in front of the board, we attach that so they have an idea of what the, it's just
What
a
it looks
draft.
like.
Sure, as a draft.
Yeah, the other thing I just want to follow up on, I think we have to start asking the town to start funding MES a little bit more on this, because a natural pushback from others is we're continuing to do legitimate demonstrations, some might say research studies for oysters. but why not I&A system? Why not eco-toilets? Those are emerging technologies that could use, and it's a fine line that eventually other departments have to pick up. Or your money's gonna be running out.
True enough. Yeah.
MES, fund.
Marine and Environmental
Yeah.
Services.
I mean, more money for the town department
So
that's
Yeah.
gonna do
you
this
mean
work.
lobby for an increase in their budget?
Yes.
Is what you're saying?
You're right.
Well, we should.
Because we're not the research
Because you're
center.
right, no, we're gonna be unloading this, and they're gonna be doing it, so they
Right.
should definitely have the resources to do that. I think we need a vote in the motion.
I move that we apply for the grant.
Moved and.
From the Woods Hole C grant.
Here a second?
Second.
Okay, further discussion, all in favor?
Aye.
Aye.
Opposed? You guys
Is
have
that Steve on the main motion?
Yes.
Thank you. Don't take minutes. I don't
it.
Make it up.
I don't make it up.
You can watch it on TV.
Well, it's note-taking, you can say a motion was made and accepted. It's a questionable thing whether you have.
Oh, you don't have to put the person?
Well, some people would argue with that.
It was all in favor, though.
It's the motion that was accepted and passed. It's given that it has to be made properly.
Good point.
Okay, report of members and staff. Do we have any reports of members and staff?
I get a quick question to back up. Can I assume that we have now accepted the report we had presented in front of us today, and it can go out as final?
Yes.
Virginia made that motion, and John Weber seconded it.
Yes.
No, we're,
That's number one here.
The first report,
Yeah.
I-
Jim Baker.
we didn't make a
Oh, Jim.
motion on that.
Oh,
because there's not a motion down there in the agenda, but I mean, I
You're
think you could
You're right.
accept it and then
Right.
come
All
back
it-
with the
all it
final
says here is
report.
presentation, right. Okay, well, how about that? A motion to accept it?
well, we can do that. If you may remember, the condition, one of the conditions in getting the grant from the collaborative was that this report also be reviewed by the Cape Cod Commission, Tom Cambereri. So before
That's a good point.
it can be finalized, there has to be a meeting. And have you had a conversation with?
I've had conversations with Tom over the last couple of days.
Get him a mic.
Get a
Just on
microphone.
my phone that
Can you
You
just
need
give
a
him that mic?
Yeah, it's because we're being recorded.
And televised, they want to hear you. In
Live.
the greater world here.
I did talk to Tom Cambereri at the commission over the last couple of days, and I just noticed on my phone late this afternoon that I got a letter.
Oh.
So they've sent a review letter,
A review letter.
yes.
Okay, which I think we'd like to see.
Yes, I'll forward it on.
Okay.
Okay. So you want to hold this till the next meeting?
Yeah, I
All right,
think we can
fair
also.
Okay, any other reports of members and staff?
I could say that, we're coming close to we're out to bid for all the sewer projects. The bids are due within a couple of weeks, I think. I don't keep track of all
February
these things.
18th.
17th and 19th.
That's why I don't keep track, but I mean, so we hope to be
17th
able.
and 19th are when the bids will be opened.
Okay, that's what Jeff said today, okay?
Yeah.
And we hope to be able to award by April 1st. The other thing is the public comment period for the permit closes fairly quickly. And the state has just, well, I'll let the state announce when they're going to have, not on the permit, but on something else. I just had to set up the date when I think they should announce it formally.
Yeah, the gist of this is things are coming fast and furious now
Yes.
on these wastewater nitrogen removal capital projects, like the sewer collection system, like the pump stations, like the upgrades at the plants, like the work in Woods Hole, like the Site 7, all this stuff is rolling out now, and so you'll have some news.
None of the balls have broken when they hit the
Yeah.
ground. They bounce up.
Right. The biggest news, which I don't know if the rest of the world knows, but we got our 0% loan.
We got DEP to accept it, again, bureaucracy. The Water Pollution Abatement Trust is the ones that are fish. I think one doesn't do I don't expect them to change it, but I don't want the press to say, we got it.
Well,
DEP approved it.
The letter from Steve McCurdy was from the Water Pollution Trust.
No, he's from DEP.
But he administers this.
No, it's a separate, Susan Perez, trust me, it's another bureaucracy, it's a
Okay.
difference without distinction, as far as we're concerned, but
Okay.
I don't want the press to get it wrong.
So Mass DEP has approved the 0% loan.
And
That's
it has to
good.
go to the WPAT, Water Pollution Abatement Trust.
Pollution Abatement
And that
Trust.
sometimes comes in a little bit later than the treasurer and other people would like to see it, but it's almost, it is a given.
Okay. It's a perfunctory step.
Any other reports of members and staff? Minutes of the prior meeting.
They have been
They-
drafted. Yes.
They have,
We're going to
they,
slip out if you don't need us.
No,
we're going to
thank
be
you.
done in 1 minute, because we don't have the minutes.
We don't have the minutes yet.
Okay, so minutes, we'll have to wait for
They're
the next
coming
meeting.
shortly.
Motion to adjourn?
So moved?
Second. Discussion, all in favor?
Aye.
Aye.
Opposed? The ayes have it, thank you very much. This meeting time may not work out based on